Hi, this is David Hillier here, and I am back after a short summer break with a new set of videos. Now, I will be carrying on from where I left off, which is in chapter 10 of my book, and specifically today I will be talking about the risk and return of portfolios. Now, this chapter carries on directly from this video carries on directly from the previous video, which is looking at the risk and return of individual securities. So we are now extending this to portfolios, and that is where you bring two securities together into one portfolio. And I'll be giving you the formulae to work out the return and the risk of the portfolio, and I'll also talk a little bit about diversification, which is the benefit that you get from bringing securities together into a single portfolio. So, what we're going to do is we're going to start off with looking at the return on a portfolio, and then we'll go on to look at the variance of a portfolio. Now, why would you want to create a portfolio? If you've only got investment in a number of individual securities, and it might be that you've only invested in one security, that one security will give you a return, and it will give you a level of risk, which we measure by variance. But that return and risk combination may not be to your liking, and you may want to change it or vary it somewhat. And that's why we have portfolios. You bring securities together with different characteristics, different return and risk characteristics, and by bringing those together, you can create your own investment that has your desired expected return and your desired risk. And that is portfolio mathematics or portfolio theory. The theory, actually, now that I've said theory, this isn't really theory. This is just mathematics. It's mathematics that you would get in any mathematics degree. We don't have any real assumptions here. We're only just playing with numbers. So I would like to remind you of the data that we used in the last video. And we had two companies. One was Supertech and the other one was Slowpoke. We have the expected returns of both of those securities. If you see that Supertech has a higher expected return of 17.5% compared to Slowpoke's of 5.5%. We also have the variances, and commensurate with the higher expected return, Supertech also has a higher variance. The standard deviation of returns is simply the square root of the variance, and we can also express standard deviations in the underlying units, which in this case is percentage. So you see that Supertech has a standard deviation of 25.86%. And finally, we have covariance and correlation, which is a measure of the relationship, the intermovement between both securities. And you see that the covariance and the correlation are negative, which suggests that when one has a positive return, the other will have a negative return. Now we're going to use this data to find the expected return in a portfolio of the two securities and also the variance or the risk of the portfolio of the two securities. Now we have to start off by saying that we're going to invest in so much in one of the securities and so much in another security. And we're going to start off by saying that we have £100. And we're going to split that £100 into £60 going into Supertech and £40 going into Slowpoke. Now the weights then of each security in your portfolio are 60 over 100 for Supertech, so that's 0.6, and 40 over 100, which is 0.4 for Slowpoke. Now the weights must add up to 1. That's one of our fundamental criteria in portfolios, that the weights of all the assets must add up to 100%. So we've also got the expected returns of both Supertech and Slowpoke. And if I take you just back to the previous slide, you can see that the Supertech expected return is 17.5% and the Slowpoke expected return is 5.5%. So we're investing 60% of our money in Supertech, which has an expected return of 17.5%, and 40% of our money in Slowpoke, which has an expected return of 5.5%. Now, the expected return in a portfolio is simply the weighted average of the expected returns of the individual assets. And we can see that from the formula. X is the weight, R is the expected return. So the weight of A, the weight of Supertech, times the expected return of Supertech, plus the weight of Slowpoke times the expected return of Slowpoke gives you the expected return on your portfolio. And the expected return on your portfolio is 12.7%. Now we're now going to calculate the variance of a portfolio. The variance of a portfolio, the formula is more complex because we're dealing in squares, and you can actually see that there's two components to the formula for the variance of a portfolio. There's these squared terms, which is the weight of asset A squared, or the weight of Supertech squared times the variance of Supertech, and you have the weight of Slowpoke squared times the variance of Slowpoke. So they're the same here. And then you have this other element in the middle, which is 2 times the weight of Supertech times the weight of Slowpoke times the covariance between Supertech and Slowpoke. And the covariance figure is what we have here. It's this figure here. So if we've invested £60 in Supertech and £40 in Slowpoke, then the variance of our portfolio is simply what's given here. 0.6 is the weight of A, but if we square it, it becomes 0.36. Multiplied by the variance of Supertech, go back here, we see that the variance of Supertech is 0.066. That's what we've got here. We have 0.4 invested in Slowpoke. We have to square that because of this part of the formula. 0.4 squared is 0.16, multiplied by the variance of Slowpoke. And then we have this bit in the middle, which is 2 times the weight of Supertech times the weight of Slowpoke times the covariance between Slowpoke and Supertech. And that gives us a value for the variance of the portfolio to be equal to 0.023851. So from this data, which we've come using this data, we've arrived at the variance of the portfolio. Now I'd like you to compare the variance of the portfolio to the variance of the individual assets. Now the individual asset variances are 0.0668 and the variance of Slowpoke is 0.013. When we look at ours of the portfolio, the variance is 0.023. Now we're going to spend a little bit more time on this now because I want to show you how creating a portfolio can actually reduce the risk of your overall investment. So one way of looking at this is to look at or break down the elements of the variance formula. Now this here is simply this formula broken down into a matrix, and you can see that there's the squared terms, and then you've got the weight of Supertech times the weight of Slowpoke times the covariance between Supertech and Slowpoke. But from the formula you see that there's a 2 there, and what we've got is we've got this appearing twice in this matrix, and so therefore we have to multiply it by 2. So the formula for a variance of a portfolio is simply the x squared times sigma squared plus x squared times sigma squared of the two assets, plus 2 times x A times xb times the covariance between A and B. Now what we've got here is we've got some square terms and we've got this multiplicative term, and I'm going to come back to that. If we want to calculate the standard deviation of the portfolio, however, we just take the square root of the variance. And since the variance was 0.023851, we take the square root of that and we see the standard deviation is 15.44%. So compare that with the standard deviations of the individual assets, 25 and 11. The standard deviation or the risk of our portfolio is closer to Slowpoke, even although we've invested less in Slowpoke, and I will come back to that. So, looking at these squared terms, we have the variance of a portfolio is equal to x, the weight of asset A squared times the variance of asset A, plus the weight of asset B squared times the variance of asset B, plus this term here. Now, if we forget about this term, these terms, and we only think about this point and this point, and take this and think, well, okay, if we just have the weighted average of the variance, which is XA times standard deviation of A plus XB times standard deviation of B. So that's the weighted average of the individual standard deviations, which is similar to what we had with the weighted average of the expected return in the portfolio. By forgetting about these terms and we just look at the standard deviations, then the standard deviation of our portfolio is 0.1544. We calculated that here. It's 15.44%. By just taking the weighted average of the standard deviations, we get 0.2012. So the variance of a portfolio is less than the weighted average of the standard deviations, which tells us that we actually have some benefit from creating portfolios. Because if we just had the two assets and we said, well, okay, the two assets, the expected return of a portfolio of those two assets is just a weighted average of the expected returns. And if we said that the variance of a portfolio or the standard deviation of a portfolio was just a weighted average of the standard deviations, then there's no benefit from creating a portfolio. But because we have this effect that the risk of a portfolio is less than the risk of the weighted average of the individual asset risks, that investing in portfolios is better, it's more efficient than investing in individual securities. And that comes from what we call diversification. Diversification means that you are taking risk and diversifying it. And the diversification is a process of diversifying that risk. So we're keeping the returns, but we're reducing the risk. And that is good, and that is a positive. So it's beneficial to you to diversify your risk because you are maintaining your level of return, but lowering the overall risk of your investment. Now, does this happen all the time? Well, I can say that as long as the correlation between the assets in the portfolio is less than 1, that is, they are not perfect substitutes, then diversification will be of benefit. It will happen that the standard deviation or the risk of your portfolio will be less than the risk of the weighted average of the individual securities. Do you believe me? Well, I'm going to show you some data. What I've done is I've gone on to just the Euro Stocks Index, and I've looked at the standard deviation of returns for a number of companies that are in the Euro Stocks 50 Index. Now, the Euro Stocks 50 Index is the index of the largest 50 companies that are traded in euros. And basically they span the whole of Europe. Now you can see that it's 50 companies. We look at the individual company standard deviations, and these are massive firms. But the standard deviation of the portfolio is significantly lower than the standard deviation of the individual securities. So again, I've shown you mathematically that bringing assets together into a portfolio will improve the risk of your overall investment. That is the diversification effect, but I've also shown you using real data. So thank you very much. That video will allow us now to go into a bit more theory in the next video when we look at efficient portfolios. And efficient portfolios allows us to then move to the most important, or one of the most important models in finance, and that is the capital asset pricing model. Thank you.